How to continue assembling screws from any position in the middle. Assuming that there is no problem in the single-step test, I want to start assembling the product directly from the middle position. Start assembling from the third coordinate. Select the coordinates and press to move the cursor position. Camera facing the screw hole. We check the screw holes to see if there are already screws. If there are no assembly screws, then press cursor start key. After pressing, the screws will be automatically assembled backward from the current coordinate position. The machine will finish all the remaining unassembled screws. When it comes to new LED module products, we just press start. In this way, the program production and testing inspection are completed. Here's how to troubleshoot our common problems. The first one is screws not being detected and how to troubleshoot. Let's create problems and make the machine's alarm. In this way, the sub-sensor does not detect the screws and the vibrating feeder keeps pushing the screws. The feeder continuously supplies screws. After reaching the set number, the machine will alarm and indicate an abnormality. The machine will prompt requesting screws failed. An alarm is generated and we will investigate. There are several possibilities that can cause such a failure. The first one looks like ours. The pipe is stuck and cannot be unblocked. The screw cannot pass. There is also an alarm, which is that the feeder is stuck or there are no screws. Another problem is that the sensor does not detect the screw. These three situations cause this alarm. Then how to deal with it? E. Check whether the trachea is clamped. R. Check whether the vibrating feeder is stuck. Check to see if there are any screws stuck here. Remove the stuck screws. Press the feeder test and the feeder starts to move. Resend the screws. Check whether the feeder is operating normally. Let's take out the screws from the trachea. The feeder operates normally. We first press the screw to feed and then press to relock. Then manually remove the screws. We check the screw working head and there are no extra screws inside. Cleaning screws completed. Then press this driver to test. We press it and the machine automatically sends a new screw. See if the indicator light is on. This is how to deal with failure to detect screws. Another is to check the sensor debugging method. If replacing the sensor with a new one, we first rotate it so that the indicator light turns red. The red light is on when metal is detected around the area. We then rotate back so that the green light comes on. After the light turns green, we check using the metal test. During the test, the red light was still on. Continue to rotate back. As you can see, this is the only one that is very sensitive. This is the normal state. Introducing the next alarm. It just reports a sliding tooth error. Let's turn on the alarm check. When we turn on the detection, we can test the effect. There is no LED module now. You can see the effect after I press start. Once the machine is assembled, the machine will immediately alarm. The sliding tooth alarm is displayed here. Alarm problems are caused by the following situations. One is that the torque is too high. We use a screw tool to check whether the screws actually have slipping teeth. Too much torque will cause the screw to slip. For this kind of problem, let us adjust the torque a little bit. The torque is adjusted by modifying the torque parameters of each working head in the display. The other is that the alarm is generated when the assembly screw time we set has expired. Display this sliding tooth alarm. The processing method is to test according to the driver first. If you want to assemble the next screw, press the start button. Then there is also a screw thread sliding alarm. Also, the assembly screw time is set to short and an alarm occurs. It's just that the time for assembling the screws is set to short. The machine torque has not yet reached the target value, but the time has been reached. The machine reports a sliding tooth alarm. Let us increase the target time. This time parameter. Normally, we set this time to 1.5 seconds. Probably, set it according to this time. That's probably it. There is also a problem that causes the machine to report screw slippage. That is, the batch rod is too short and there is no contact screw to alarm. You see, like this bar, the length is shorter when it is extended. It sticks out just short enough not to hit the screws. The motor keeps spinning. How do we solve this? Make the protruding length of the batch rod longer. Loosen this nut. You can see that the current length is roughly like this. We will check the effect after debugging. After loosening the nut, turn it downwards. You see, the length that stretches out becomes longer. After debugging is completed, tighten the screws. But our machine has been debugged normally before it leaves the factory, so you don't need to debug it. The introduction to the alarm issue is complete. The reset button is to return X, Y, Z to the original position. Relock means the Z-axis moves up and down. This is the working head rotation of the driver test. This button is the screw feeder. Blow the screw into the inside of the work head.